Alrighty, so in today's video we are going to continue solving systems of equations. In the last video we solved by graphing, but we aren't always going to want to graph, or it might be way too much work, or the solution might not be a nice numbers that'll show up on a graph. So we have to have different ways of solving. And that first algebraic way is going to be called substitution. So think about when you're substituting, like if there's a substitute teacher, that substitute is taking the place of the full-time teacher. So that's going to be kind of the same idea that's going on here. So there's steps for substitution. When necessary, you have to get one of the variables by itself. So when necessary, solve one of the equations for a variable. Get the variable by itself. Then take what that variable equals, so substitute the resulting expression into the other equation to replace the variable. So now, where you substitute it in, you need to now solve that equation. So that'll give you one of the variables. You'll be solving for either x or y or whatever the variables may be. So that's how you're going to solve for one of the equations, or one of the variables. Then you substitute that value into either equation to solve for the other variable. So then you'll have solved for both variables. So to close it all out, you just write the solution as an ordered pair. So for a precursor to this, so just so you see what we've been, how this really works, like substitution works, if I told you y equals 3, and then I gave you the equation 2x plus 5y equals 13, well, I know y equals 3. So think about what equality means. It means the left-hand side and the right-hand side are the same exact thing. So if y equals 3, I can take this y and I can replace it with 3. So it'd be 2x plus 5, but instead of y, I'm going to substitute in 3 for that y equals 13. And now this is an equation that I can solve, because I did have x and y, and I don't know how to solve for both x and y at the same time in one equation. But when I do a substitution, one of the variables is going to go away, and I can actually solve this now. So like 2x plus 15 equals 13. 2x equals negative 2, so x equals negative 1. When we make that substitution, we can now solve this equation for one of the variables. So let's look at what this some of these problem types, if I want to solve these systems using substitution. So you'll notice in the first one, our system is y equals negative 2x plus 4 and y equals x plus 1. Well, both of these equations have y by itself. So since y equals negative 2x plus 4, everywhere I see a y in the second equation, I can substitute in negative 2x plus 4. Okay? And then I just drop the equal sign, and that's going to equal x plus 1. So you'll notice we use that power of substitution because y was by itself. Y equaled negative 2x plus 4. So I take that negative 2x plus 4, everywhere I see a y in the second equation, I substitute it in. Now I have an equation with just x's, which I know how to solve. Okay, I'm going to add 2x to both sides. So I'm going to get 4 equals 3x plus 1. Subtract 1, and I'll have 3 equals 3x. So x is going to equal 1. Now, to figure out what y is going to be, I'm going to take that x value and I'm going to plug it in to either equation. It doesn't matter which one. Alright, so I'm going to plug it into the second one. I want to figure out what y is. So it was y equals x plus 1, but I now know that x equals 1. So instead of x, I'm going to plug in 1. So 1 plus 1, y is going to give me 2. So my solution there is 1, 2. All right. let's say you decided to plug it into the other equation. I want to show you that you're still going to get y to be 2. So the first equation is y equals negative 2x plus 4. But I know x is 1, so I can plug in 1 for x. And when I solve that, I get negative 2 plus 4, so y is going to equal 2. It doesn't matter which equation you substitute back into, because you're going to get the same answer as long as you substituted correctly for your first variable. And then remember, guys, check your answers. Check your answers. If I plugged in 2 for y, and then equals negative 2 times 1 plus 4, negative 2 times 1 is negative 2. So negative 2 plus 4 is 2. So the left-hand side equals the right-hand side. Alright, I can check it in the other equation as well. Plug in 2 for y, plug in 1 for x. 1 plus 1 is 2, so 2 equals 2. Remember, a solution to a system of equations is the ordered pair that works for both equations. Alright, so let's go on to the second problem. Our system is 2x minus 2y equals 10, and x equals y plus 5. So we already have a variable by itself. In that second equation, x is by itself. So I'm going to take what x equals to. I'm going to take that y plus 5, and I'm going to substitute it in for every time we see an x in the first equation. So the first equation is 2x, but instead of x, I'm going to substitute in y plus 5. And then I've got the rest of the equation, which I just want to copy down verbatim. So then I have this equation, which now is just dealing with y's. It's just one variable. I can do that. So we distribute, we get 2y plus 10 minus 2y equals 10. And then if I combine like terms, well, you're going to get 2y minus 2y. That's going to go away, and that's going to leave you 10 equals 10. Well, if your variable went away, then you're either going to have no solution or infinitely many solutions. Think back to videos from several units ago when we looked at infinitely many or no solution, those types of solving problems. So if 10 equals 10, that's an always true statement. And so if it's an always true statement, there are going to be infinitely many solutions. Whatever ordered pair works for the first equation is going to work for the second equation. So in the previous video, when we were solving by graphing, if we graphed those lines and they were the same exact line, that was infinitely many solutions. So now when we're solving algebraically, if we get a true statement, if our variable goes away and we're left with a true statement, that's going to be infinitely many solutions. Okay? Which means that in my system, 2x minus 2y equals 10 and x equals y plus 5, if I were to graph those, they would be the same exact line. Alright, let's move on to C. So in C, our system is y minus 2x equals 3 and 6x minus 3y equals 4. So in this one, before I can substitute, I need to get a variable by itself. Well, you'll notice in that first equation, y is super close to being by itself. All I need to do is add 2x to both sides. And if I do that, y is going to equal 2x plus 3. Now I can substitute. I can take that 2x plus 3 and plug it into the second equation every time I see a y. So I'm going to have 6x minus 3. Instead of y, I'm going to substitute in 2x plus 3. And then that's going to equal 4. So I'm going to distribute that negative 3. So I'll have 6x minus 9 equals 4. And then notice what happens. Once again, our variable goes away. 6x minus 6x is 0. So I'm left with negative 9 equals 4. And that is false. That's never true. So remember, if your variable goes away and you have a false solution, then you are left with no solution. If you solve and you're left with a false statement, like -9 equals 4, that's never true. So because that's false, this system of equations has no solution. So remember, if I were to graph these, they would look like a parallel line, a set of parallel lines, because they would never intersect. All right, we've got one more to do. We've got D. Okay, we got 3x minus 4y equals 28, and x plus 2y equals 6. So remember, before I can substitute, I need to get one of my variables by itself. This second equation, the x is really close to being by itself. All I need to do is subtract 2y from both sides. So my second equation is going to become x equals 6 minus 2y. And now that x is by itself, I'm going to take this 6 minus 2y and I'm going to plug it into the first equation every time I see an x. Because 6 minus 2y equals x. So I'm going to take 3 times, I'm going to substitute in 6 minus 2y, minus 4y equals 28. Distribute the 3, so I'll get 18 minus 6y minus 4y equals 28. Combine like terms, 18 minus 10y equals 28. Subtract 18 from both sides. I'll get negative 10y equals 10. So y is going to equal -1. Alright, so I solved for one of the equations. Now I need to go back and solve for x. So since I solved for y, since I got y by itself, I solved for one of the variables, I'm going to take that y value of -1 and I'm going to plug it back into either equation. So like if I plug it into the top equation, I'll have 3x minus 4y instead of y. I'm going to plug in -1 equals 28. So if I solve this, 3x, -4 times -1 gives me +4 equals 28. If I subtract 4 from both sides, I'll have 3x equals 24. So x equals 8. All right. So the solution here is 8 comma -1. I also want to show you guys that if you decided to plug it into the second equation, you should also get x equals 8. So we had x plus 2y, but instead of y, I'm going to plug in -1. And then that equals 6. So I'll get x minus 2 equals 6, so x equals 8. Doesn't matter which equation you plug in your first variable value into, you should get the same answer. Now remember, you can double check your work here. Plug in 8 for x, plug in -1 for y, it should check out. And if it doesn't, you did something wrong. You need to go back and fix it. So, like in D for that final example, remember, if you were to graph these systems of equations, those two lines would intersect at the point 8, -1. All right, so that's substitution. Get a variable by itself, substitute the expression into the other equation, solve it, substitute it back in, and then solve for the other variable. It's a lot of steps, but hopefully you're kind of getting the grasp of it. Make sure you ask questions if you got it. As always, be good, and I will see you when I see you.